Good evening, ladies and gentlemen. Good evening. Welcome to the first in our public lecture series for the 2023-2024 academic year. The public lecture series is one that is telling and one that impacts the full range of the Caribbean. And it's a little bit too much for us, and it's a little bit too much for any one island to handle and any one person to handle. So today we have the topic too hot to handle. And when we say too hot in a tropical context, it's telling. It's telling because we are looking through a lens that climate change has changed the landscape. Global warming has changed the landscape of the Caribbean. But those impacts aren't always well elucidated or well voiced. So today we have a dynamic panel ranging from the Meteorological Service to occupational health. And so our first speaker is going to be that of Miss Jacqueline Spence Hemmings, Mrs. Jacqueline Spence Hemmings from the Met Service, and followed by Dr. Blackwood, then Mr. Leonard Fulton, then Dr. Brian James, then Dr. Norbert Campbell. At the end of that, we will take any questions that you have. So please feel free to type in the chat any questions you may have, and we welcome you to our presentation, our first in the series, our Science Today series. We welcome you. I am Jay Campbell. Please note I'll be moderating today's proceedings, and I am a climate change specialist by nature, so I find this topic relevant, important. And just before this, I made cursory calls around the Caribbean, and everybody's saying it is just too much to bear. But what does that mean? Our first speaker is going to actually set that stage. And in setting that stage, she's going to set that stage in a way that only she can. Mrs. Jacqueline Spence Hemmings has been employed with the Meteorological Service for over 21 years and currently serves as the head for the climate branch. In this capacity, Mrs. Spence Hemmings is responsible for the management of the data collection network, which covers the length and breadth of the island, as well as engaging in research activities in the development of climate change services and products to inform decision-making and resilience building of various sectors of Jamaica. Can you understand why Ms. Spence Hemmings goes first? She goes first because her data touches every aspect of our lives. And so without further ado, I'm welcoming Mrs. Spence Emmings to the stage.
Thank you, Dr. Campbell, and good evening, fellow presenters, or good afternoon. Let me go right into the presentation. Okay, and I hope everyone can see the slide. So I decided to use a little bit of patois. I think we are all Caribbean people here, so we'll understand. Now, who turn up his son? And we begin by setting the context with recent findings of the IPCC from Working Group 2 contribution to the 6th assessment report, which deals with impacts, adaptation, and vulnerability. And I've highlighted just 3 points. 1, human-induced climate change has caused widespread impacts and loss and damage. I know we've been hearing a lot about that term, loss and damage. But more importantly, what we are finding is that some of these impacts are irreversible. Now, that is not a word that we ever wanted to hear, but we are now hearing it in the context of climate change. Weather and climate extremes are on the rise, pushing people and ecosystems beyond the limits of what they can adapt to. And the most vulnerable, guess who? Small islands like Jamaica are at the forefront. Almost half of the world's population is living in contexts that are highly vulnerable to climate change. Increasing weather extremes, including tropical cyclones. We are currently in the hurricane season and praying we don't get hit. And these are driving displacement of people around the world. No, I don't know about you, but we all live on an island, so I don't know, getting displaced, where do we go? As I continue to set the context, I just want to share with you what we call the rainfall pattern for Jamaica. And it basically is divided into 2. We have a secondary and a primary peak. The secondary peak occurs around April to June, and the primary peak is August to November, which of course coincides with the hurricane season and would be the period we get most of our rainfall. So what have we been observing? Well, let's start with rainfall pattern. Well, you can see clearly from this map here, the red represents below normal and the blue represents normal or above normal. And for most of the months, and especially when we expect most of our rainfall activity, which would be for the rainy season, we are seeing reds below normal. So that is quite concerning. That was 2021. Looking at 2022, not much better. We did get some rainfall in April above normal, but then it quickly disappeared for May. June, again, was considered below normal. So this pattern of longer drought periods, less rainfall, more variability in the rainfall is being seen. So next we look at drought, because lack of rainfall obviously will mean that we are getting in drought. And this graph shows the number of parishes with 3 or more occurrences of drought, which is usually in most instances one after the other. You will see numbers like 10 parishes, 8, 7. Now, when we have so many of the parishes reporting drought, we don't have to ask if the parishes that are responsible for the crops which we all depend on to feed the country, we don't have to ask if usually they are in drought and therefore having serious issues. So then we look at the most topical issue, and that is of temperature. And we see on this map, we're looking at maximum temperatures recorded at Hamden, and this is in Trelawney. We can identify that 2020 really hit it out of the ballpark. We're seeing temperatures rising, and they started trending down a bit 2021, 2022, but clearly 2023 has decided that no, I'm heading right back there. And going through April, May, June, you see slowly the temperature is higher and higher, 36 degrees, 37 degrees Celsius. These are not normal temperatures, people, just in case you're wondering. Looking at Norman Manley Airport, and these we have longer records for the airports. Again, we are seeing where the trend of the higher temperatures are being experienced. This is the mean maximum. On this side, we have mean maximum temperatures. So on average, would say that between 31.2 and about 33 is, sorry about that, is normally average for April. It gets a little warmer for May and continue, but it should start go down around about August when we would normally get rainfall. Now, for this year, what we're seeing is that instead of going down, some of the temperatures actually went up. And I can quickly go to Sangster, where you'll see a clearer pattern of increase in temperature. You can actually see the rise in temperature for each month. You literally see the pattern going up. You can draw the line showing the increase in temperature from, and this is April through August. Again, this period is 1990 to 2023. So this is a similar case for Sangster Airport, but for Sangster, we were seeing higher temperatures than Norman Manley. So then we look at the length of the spells. And for April, we were okay. We didn't have much happening in April. But May, that quickly changed, where we had a shoot up. We had a shoot up for 2020, that this one looks like 2021. But for in June now, we had 2 consecutive days of temperatures greater than 34 degrees Celsius. In July, we went up as high as almost 7 days. In August, we surpassed that, heading up to 8 days. Looking at Sangster, now Sangster is where we saw some interesting numbers. For April, we didn't have much. We had zeros there, but May quickly shot up 3 consecutive days greater than 34 degrees Celsius. For June, we are gone to 8 consecutive days of greater than 34. For July, we have surpassed 15 days. For August, we are at 25 days. So imagine having 25 days of temperatures greater than 34 degrees Celsius, people. That is, I will say, not normal. And this graph is just to show, we picked up just a few of the automatic weather stations that are across the island. We don't necessarily have long-term averages, but because our temperature does not vary that significantly, except for our microclimates, we pretty much see a similar pattern where we started off June 30s, by July heading up to the 33, and most of them would shoot up. Some went down for August, but most generally went up or remained at very high. And we see that a lot of them are above 35 degrees Celsius. What we noted, Mason River is considered a microclimate, and in summer, although we expect temperatures of 30s or so, Mason River is one of those places where you probably would get high 20s. But instead, here we're seeing Mason River quite up there with 33. And similarly, Worthy Park, also another microclimate, heading up to 35 degrees. This is not normal for these places. As I said, these are places that even in the summer times are cooler than your regular, whether if you're thinking about May Pen or Kingston, these places would be cooler, but they too are showing this increase in temperature. And who remembers 2017? 4 hurricanes in the Atlantic at one go. This picture is showing them three were category 4 and 1 was category 1. 4. And this is what we are expecting to continue, or what could happen again or become even worse. So some questions that I leave you with. For the agricultural sector, how do we continue to ensure food security with greater irrigation needs, more variability in rainfall, and more problems with heat stress? Water sector, can the vital resource continue to be sustainably provided to the many and varied areas with the variability in rainfall and longer drought periods? Fire safety, drier periods means increased likelihood of bushfires. How do we reduce this likelihood? Health sector, prolonged dry periods result in allergies and other illnesses. Heat stress for elderly, small children, pregnant mothers. How do we respond? Construction sector, schools, nursing homes, offices. Will we have to rethink current building codes for a warmer climate? And something I should have added here, will we have to reconsider the times when persons can work? Because if you think about it, they work outside. If it is so hot outside, can they work the regular hours, or will we now have to work at night? Something for us to ponder as I close. Thank you.
Wow, I'm astounded by some of the data. I have worked with a lot of that data. I'm astounded by the data. I have worked with a lot of that data before. And what I am left with is a sense that you don't know until you see it presented by somebody else, by the expert. Now imagine a month where temperatures exceed that normal for 20-something days. And as you heard the questions at the end, what does that mean for persons working out in the field? Imagine if that happens in a September month. Children are just going back to school, eager to go to PE, eager to do the outdoor activities. What does that mean? Are we getting to the point where normal isn't normal anymore? Are we getting to the point of a new normal? Now, the questions at the end are telling, and you can see how we've juxtaposed the data for the sectors. Now, with that said, I'm going to invite Dr. Jenna Blackwood, right, to the stage, but she's practicing landscape architect and environmental consultant with approximately 30 years of experience in the industry. She has worked in the public and private sectors on a range of projects, such as hotels, residential and commercial developments, including tourism attractions and regional development and plans. Her PhD research focused on household stormwater management and the structure of stormwater governance in Barbados, Jamaica, and St. Lucia. She's also an adjunct lecturer at the Caribbean School of Architecture, where she teaches introductory courses in landscape architecture and environmental management. I can't think of a better person to answer the question on that landscape issue. Welcome, Dr. Jenna Blackwood.
Thank you so much for that introduction. I hope you're seeing the screen.
We are.
Great. And thanks to the faculty for inviting me here. So I hope I'll be able to shed some light and continue this conversation. So the topic I have, climate change and landscapes, and I've thought of focusing using nature to beat the heat. We know that we have heat. How can we incorporate nature into some of this? So first, I'm just setting the stage of what is a landscape. I mean, when you talk about landscapes, people sometimes, and when I say I'm a landscape architect, people think I'm talking about plants and, beautification. But really, the landscape is the large area that when you look out of your window, that's what you're seeing. And my role is I am the planner and the person who designs or alters some of these landscapes that you might see. So when we talk of landscapes, we all live in what we call a landscape, and we define these landscapes depending on the features that are there. So we have what you have in the top left, you call that a coastal landscape. We have an agricultural landscape at the bottom left, and we have that mountain landscape that you're seeing. So as humans, we do a lot of things. We live in a landscape, but we also make a lot of changes in the landscape. And so we can look at the kinds of changes that we have made, and maybe how some of these changes have been good or bad. The city is a landscape, and everything contained in the city. Here is a now old image, something I got from the internet, because I'm sure with the buildings that are going on right now, the cityscape probably looks a lot different to what you're seeing here. But in this image, you can definitely see there's more of an urban core. You'll see the high-rise buildings somewhere in the center, and then you can see the smaller scale buildings that are surrounding that. So I'm going to look now at, you're looking at the climate at the different scales. And Mrs. Spence Hemming, she mentioned macro and micro. And so I am looking at, I've included another one that I've called meso, which is like a mid-range. And some of these, like she said, at the macro, there are things that we cannot change. We are experiencing a climate that we are not used to. And so me as a designer, there's nothing that I can do that can affect or change that. And that is the realm of the climate scientists like Dr. Campbell here. So they're looking at the broad scale. They're telling us about all the climate trends. And then you have the international, at the international level. And then I'm looking a little further down at, you know, maybe like a community level. And this is what Mrs. Spence Hemmings, she's talking about. She can tell you what's happening in the different regions. She can tell you what's happening in Mobay, what's happening in Port Antonio, what's happening in Morant Bay. And that is at the responsibility or the purview in that local government realm. And then there is what I now would look at the microclimate level, which is actually what an individual might experience. And I can bring it down to the level of your front yard versus your backyard. You could find that you've got a different condition in your front yard and another condition in your backyard, depending on the sun path, depending on the winds, depending on, you know, moisture, if you've got plant material. There are lots of factors that play into that. And that is the level that you do have some amount of control of. When you go into the higher levels, there is, you know, you don't have as much control. So one of the things, and it's just so coincidental, Mrs. Spence Hemming, she mentioned this. Some years ago, there was a study that came out in 2013 by a scientist, Mora. He is in Hawaii, and he said at that time that Kingston was going to be the first city in the Western Hemisphere and the second in the world that would experience climate departure by 2023. We are currently in 2023, and we are hearing this today, this afternoon, about temperatures that are abnormal, unprecedented. We've never had this kind of thing before. So I would leave it up to Mrs. Spence Hemmings and Dr. Campbell to then tell me, was this prediction actually correct? Are we now at this point of climate departure? For the rest of the presentation, I'm going to focus now on these lower levels, and we'll look at some of the things that happen in these at the lower level. So my focus, because we're talking about heat, is going to be at the urban level or in the urban sphere. And I'm looking at this phenomenon, which is called urban heat island effect. I don't know if people have heard about this, but what this is that in your built-up areas, so even though we do have changes in the climate, you know, in the atmospheric temperature and in rainfall patterns, etc., up on top of that, you also find that the built-up areas actually feel even hotter than the surrounding areas. Why is that? That's because when you are building, the materials that are being used for building, those materials tend to absorb and radiate heat. We also tend to then remove plant materials, so we're changing the ecology of the space. We're not getting as much moisture that used to be in our soils. We don't have that anymore. We have, you know, congestion. We've got cars that are putting out the vapor and greenhouse gases. And interestingly, air conditioners. I'm sure that this summer, everyone or many people went out and bought air conditioners. So when you're cool inside, those air conditioners on the outside are actually putting out heat as well and contributing to the heat that we're experiencing. So you find that there are all these different factors that are adding to the heat that we already have. And this is based on our actions, and this is based on how we are designing and planning our spaces. Now, I put these images here because these are some images from different places around Kingston, okay? And, you know, the series of images at the top is at one location. And I can say that you can see from this, it looks hot. It looks hot, not just because the atmosphere is hot, but it is totally paved. In essence, this lot is 100% paved. The materials is surrounded with asphalt. There is no greenery. And we look at our streets. These are new streets which were just done, again, devoid of greenery. So they feel even hotter, you know, as a result. And just in case people think that, you know, what we read about urban heat island, maybe, you know, it's theoretical. I'm just going to share with you some, it's unpublished research, but one of the students who I supervised at the University of Technology, this was a master's student in architecture, and he did his research where he went around Kingston to different locations, and he took thermal images and temperatures at different locations and of different materials as you went around. So he went to Hope Pastures, he went to South Camp Road, he went downtown, he went to the Shortwood area, and he took different temperatures of different materials. And it is interesting if you, he did this, you know, for all the different areas. I just put an excerpt here. This was done between the hours of 10 and 3. 10 a.m. and 3 p.m. And if you look at the readings that he got, the difference, if you look like below the tree canopy, you're talking about a 5%. And sorry, and I'm sorry that this is in Fahrenheit. I know that we don't do, but you can just see the ranges though. The below the tree canopy is 5-degree change between the highest and lowest. And then the hardscape. The hardscape is your asphalt, and that goes up to like 28 degrees difference between the morning and the evening, right? And if you notice the difference between the canopy, below the tree canopy, and the hardscape, there's a significant difference between the two sets of readings. What you'll also see is that below the tree canopy, those readings are pretty consistent and very much within a narrow band, but the hardscape, as the evening progresses, the difference gets higher and higher as you go through the day. So it then would suggest that, you know, when you say that these materials, they trap, they absorb, and then they radiate the heat out at night, and that is exactly what he was seeing here. Something else that was interesting, metal and asphalt were almost the same. Well, they were pretty much the same temperatures, significantly higher than other materials, significantly higher than concrete and brick, significantly higher. And so it just proves to you, and at the top you'll see the thermal imaging, and you will then you can see the temperature with the asphalt being extremely hot, and the surrounding areas you can see where the tree would be, that's significantly cooler, right? Like I said, this was unpublished, so it's not, but it gives you just an idea of what we are dealing with. So it's not just the atmospheric temperature, it's also the temperatures that are around us. Another thing that I couldn't, talk about the climate and temperatures and not talk about the water cycle, because urbanization again affects our water cycle. And I think people don't think of that, where you had this perfect, or you learn about this water cycle, and the water goes into the soil and it runs into the rivers and streams, etc., and it comes back around. But when you now build over everything, there is no water that's going down into your there's no groundwater. And that disrupts the cycle. So it's not that the cycle is not there. It's just it's a different cycle that is there. And so things change, and we now have to come up with ways of mitigating against this by trying to come up with, or trying to find solutions that more mimic the natural cycle, right? One of the things the question that I ask myself is, if we don't give water back to the environment, how do we expect to get any back? So if we're not allowing the cycle and allowing the system to function as it used to, then it becomes more difficult for us to get back in the form of rain or in the form of the rivers and the streams, because they end up drying. Some of the measures that are proposed, to change the types of materials. We hear nowadays there's something called ecosystem-based adaptation, and we hear the term green infrastructure. And that is using things like what you see here, green roofs and green walls. But the green roofs that I'm talking about are not the kind that you see where they have the pools on the top of the roof and the gazebo and things like that. I'm talking about a thin layer of soil with some kind of native material, native plants. What this does is that this provides insulation for the building and prevents the sun from actually touching the surface. So it helps to prevent it from heating up. So if you can imagine, I can think of all of our schools where they are like industrial buildings, and they are they're furnaces. So this could be maybe a simple solution to start utilizing some of these things, because this is not something that you're intended to go up and to do anything with. Once you install it, it's something that's supposed to stay there and function naturally. The other thing about it is that it also prevents, it also slows down the rainfall. So because the other thing about the disturbed water cycle or the urban water cycle is that when it rains on the paved surface, then the water runs off very quickly, very fast, and it leads to flooding, in the low-lying areas. And we know that we have been experiencing a lot of floods. If it rains for 2 minutes, all our roads turn into rivers. And part of the reason is because if you actually look, you'll see all of the water that's coming off all the driveways, all the roofs, and flooding all of our roadways. And then when it gets into a low-lying area, there isn't anywhere for it to go. Permeable surfaces, trying to change, the types of materials. And Mrs. Hemmings spoke about this. the sustainable, the urban planning and the policies that we have in place. We will have to rethink some of these for the time that we're living in and for the climate that we're living in. I don't think that we can continue to do things that the way we have been doing it and expect to make things any better. The use of natural spaces, green spaces in our built environment. When people, a lot of the times when we see people talking about green spaces, I think people think that they are anti-development, and that's not the case. They're just thinking that if we are going to change our cityscape, we need to make sure that some of nature remains, because that is one of the ways that we can mitigate against the environment that we are living in. This image, I just wanted to show an image of somewhere with trees, and you can actually look and you can actually almost feel the temperature below, in a street like this. That is actually much cooler. And when we talk about putting in trees, I know that there is a tree drive, because trees are such a simple way of mitigating against, temperatures. And also we know that they absorb carbon dioxide, so they help with the removal of the greenhouse gases, in the system. But one of the things that I think people don't realize is when you're planting trees, and this is why I particularly chose this image, you need the space for the trees. The trees, if you see here, what is on the top, what you're seeing on the top, it has to be balanced by what's on the bottom. And so you have as much of a root system on the bottom as what is on the top. And in order to really benefit, to get the full benefits from the trees, they need to be able to get to the size, to a mature size, when they can actually start providing all of the benefits of the carbon sequestration, absorbing moisture and, transpiring and putting it back into the atmosphere, things like that. And if I get down now even to the individual level, these are other things that maybe can be done at your home that can help you. It won't prevent the extreme temperatures, but it could make your environment a bit more comfortable. Again, the strategic location of where you put a tree. If you have your sun path, and we know where the sun path is, you put a tree where you can get the shade. And if it's not a tree, there are other options where you can use other types of plant materials. You can use other materials, trellis. You can use other things that help to prevent the sun from actually touching the face of the building, so that it does not get as hot as it usually would. Your orientation, to ensure that you can capture breezes that come across the property. And again, using plant materials to try to funnel or to channel these breezes so that it creates, that flow. My architecture colleagues, because I'm not a building architect, but my architecture colleagues can help you with design of a building that encourages convection and air movement through the building, so that you can minimize the use of air conditioners and things that require energy, that puts us in a spiral, because it puts us in a spiral where we then need more energy. We're then pushing out more greenhouse gases, and just adding, on top of what is existing, what is there. Adding moisture, if it's possible, and something simple, even a bird bath, where, you can get the moisture, which gives you that cooling effect. And using plants inside and outside. So not just outside, because inside we know that some plants purify the air, and the moisture that comes from the plants will help to make your areas more comfortable. So this is just very brief, just some quick thoughts, quick ideas, but we know that there are different things that are impacting the landscapes. We know that human action, that's the primary driver of climate change. We know that we need mitigation and adaptation methods to protect the landscapes that we do have. I didn't go into, all the other things of erosion, loss of land when we're talking about sea level rise and all of that, and how we will deal with things like that. But the thing is, everybody has a role to play in addressing climate change. And I think people think sometimes that climate change is removed from them and there's nothing that they can do. But the small actions can build, to try to make that larger change. Because by working together, we can protect the landscape or we need to try at least for future generations. It's not just for us. Thank you, everyone. I hope this has added some food for thought into the discussion. Thank you.
Again, another dynamic presentation. Thank you so much. It is far more than I would have expected. You posed some questions to me as well, which I didn't want, but thank you. And what I'm going to do, I'm going to try my best to now connect the two presentations. And in connecting the two presentations, it would lead you to the third presentation. And that's the connection I'm trying to make. Now, you hear that from the climate change aspects. Work done has suggested that since 1960, the region has been experiencing approximately 20 to 25 more warm days per year, which means we've already seen some warming, right? You heard mention of whether or not we are at that climate departure point. When analysis is done from the 1800s up to the 2020s, right? What we see is that we've gotten to a point where when we're looking for the warmest years on record, right? 2014 was the warmest year on record once. It was replaced by 2015. It then got replaced by 2016. In fact, if I'm looking for the 7 warmest years on record or 8 warmest years on record, they've all occurred since 2013, which means the last decade we've gone through has been the warmest decade yet. And so when you look at it, there is almost like a 0.4 degree difference between the 2010s and what was happening in the 2000s. Now, that 0.4 difference may not seem like it's significant on a global level, but you've heard before, you've heard about the urban island heat effect. You've heard that there are regions where typically, even if the rest of Jamaica is warm, they're cooler, have now been pushing up and have been actually experiencing temperatures similar to other areas, temperatures they've never experienced before. Now, this has an impact on our lives. And human beings try, as you've heard, we terraform the planet. We have made modifications to the planet. A part of that modification leads itself into agriculture. You see the natural segue. We've gone from the data to the built environment. And that built environment we talk about is about terraforming our planet to meet our needs. You've heard about the urban side of it. Now we're coming to the agriculture side of it. And with that, I am going to introduce you to the extraordinary Mr. Lenworth Fulton. He's an agriculturist and who was the chief executive of RAP for a period of about 3 years, from May 2013 to 2016. This follows his 12 years of service as executive director for the Jamaica 4-H clubs. Currently, he manages the operation of his own farm in Lumsden, St. Ann, which means when he's coming to talk to you, he's talking to you with first-hand knowledge. He's a graduate of the Jamaica School of Agriculture, now the College of Agriculture, Science and Education case, and the Tuskegee University in the United States, where he obtained a diploma in general agriculture and a BSc in economics, respectively. Please welcome Mr. Fulton with his wealth of experience in management, agricultural extension, economics. So please welcome him. Mr. Fulton, over to you.
Thank you very much for that introduction. And I will tell you that there's a difference between flattering and flattery. I don't know which you have achieved this evening, but I want to thank you for the opportunity to represent the Jamaica Agricultural Society on this very important topic. I will go through the slides and explain them as I go through. As I go through, I will begin with a little introduction to say climate change too hot to handle. Jamaica has a domicile population of 2.8 million to feed. That's our first objective. Currently, about 50% of our food is imported. Adverse weather condition is affecting Jamaica's ability to feed ourselves, and we need to change our attitude, improve or change our practice toward much more sustainable agriculture. When we say the 2.8 million, at any one time you will find 600,000 to 1 million more people on the island due to our own people visiting and tourism. When we talk about the sustainable agriculture, I will present going further into organic type agriculture. The organic approach to agriculture. Organic, for example, when you use organic fertilizer and farming, is worthy of our attention. The overuse of inorganic or synthetic fertilizer causes the production of various greenhouse gases, for example, nitrous oxide, which has 165 times more heat as a greenhouse gas than carbon dioxide. So at this point, when you see people come to a farm store and buy urea or any one of these nitrogen fertilizer, none of us in agriculture, nor the farm store, do not say to those farmers, listen, when you broadcast this, some of this nitrogen will escape and go into the atmosphere as greenhouse gas. So you're really damaging the whole environment and creating hotter temperatures by using these fertilizers. But I don't think we are doing that when we sell farmers the fertilizer. Studies of major rivers and streams find that 90% of the fish and 100% of surface water samples, 41% of the major aquifers contain one or more of our pesticides at direct detectable levels. So even when we are drinking water here in Jamaica, because we are pouring 3 million liters of chemical in our soils and our crop, most of it is leaching back into our waters. And therefore, we are creating an environment which is more dangerous and less sustainable. 45% of our top water samples have traces of inorganic chemical. Inorganic chemical leach their way from the fields into ditches and rivers and sloughs and affect birds and fish habitat. These chemicals fuel the growth of algae blooms, and these algae blooms remove oxygen from the water and kill our fish. For example, this big quarrel every year with Sugar Estate dumping what we call dunder in the river. That dunder, that waste is not poisonous, but it sucks the oxygen out of the water and kills the fish. So we are now creating a situation of affecting our food security. Good soil health is of paramount importance to prevent most of the above mentioned effects. And organic farming is one of the major solutions. Now we have places like National Solid Waste Management collecting millions of pounds or tons of garbage every year that could be put to a spot and you use vermicomposting to make compost, which is healthy soil for us to use. And vermicomposting is created by some special worms that break down the biodegradable garbage into good material. And so we need to practice these things. I would like to touch on another matter, the modification of farm structures. This is where we need research. The last two lecturers spoke of it. You can't expect to use zinc roof and concrete floor for our poultry and pig pens. They are the best conductor of heat. So what do you expect as the climate gets hotter? And I'm now calling on researchers to find material that would not transmit the heat, but would be as sturdy as zinc. When I was growing up, they used to use white lime and the bauxitic soil, mix them together. And that's what they make the early houses from, and they were all cool. They were cool houses. Where I grew up, that house was a shingle roof. The people in the village used to make the shingle. And I'm the last of 10 children. So when I grew up, the shingle started to get bad. So my father put zinc on it, but the shingle was underneath. So I grew up into a cool house. That's all I'm saying. We have to now think how we use our thatch, how we use various plant material to prevent that sun from hitting the zinc. So we are talking about improving by using our roof to be the base for solar energy. Because when you talk about our bird, our developed industry here, the broiler industry and the egg industry, we are losing the birds through mortality from extreme heat. Now you might have to put some fan in that building. And we are saying that it is time we put solar energy, trap it on the heat, convert it into electricity that wouldn't cost you the amount of money if you use the JPS system, which read down to fossil fuel and go back to the point where we don't want to go to, greenhouse gases. We need to construct structures to increase airflows and afford farm animals more space, including a sprinkler system to wet the animal in extreme hot weather. We know that our poultry and pig industry are on the Clarendon and St. Catherine Plain. And that was so because of ease of transportation to the two companies, to the slaughterhouses. They were not thinking about climate change when they select these sites. Now we are at a position where we have to say, we have to grow pigs and poultry in the cooler climes of Jamaica because the time is getting hotter and we have to act appropriately now. I would like to touch the topic of water harvesting because once you deal with food security, you deal with land and water. You must have water. And all farm structures, including our houses, should be retrofitted with gutters now to lead the waters into tanks, drums, and ponds. We need maintenance of catchment area that are in disrepair, and that is the man-made catchment area. You have a lot of tanks, a lot of area, and we should go back to them. We want to provide assistance to engineering works to fix some of the gullies to retain water for agriculture and industrial purposes. Why would you have a gully that can hold 10 million gallons of water and you collect the water after every rain and allow it to flow back to the sea or somewhere? So we need to start to look on these gullies and see which one of them we could retrofit that would not pose danger to our everyday existence, that you could pump back the water into the agricultural area. Because our data, if you can suffice water for 75 to 100 days of drought, some rain will fall in between. So that is where our dilemma is. We don't have a system to sustain us 100 days in a dry spell, which is roughly 3 months. We would like to investigate more underground water resources that can be harnessed. Luckily, I heard a news this morning where the Water Commission is trying to reopen a well somewhere in Kingston. And we would like to extract water from the atmosphere. There is a recent article I could send to you later, where an engineer in America has been developing a system. The system was there long before him, but I think he improved it. And one of the pieces of literature that I read, that system is sufficing water from the atmosphere to an island with 15,000 people. They get adequate water from it. Now there are areas in Jamaica with a lot of water in the atmosphere. This whole area, starting from Monegin Center and right down up the hill to Brownstown, and in Mason River and these places mentioned earlier. That whole stretch, the whole area in Centan going back up into Fraser, Battersea, Bohemia, all these areas in K Valley. These are areas with heavy mist that we could now start to look on how we get water. So we have a lot of work to do. We must now look on how we would improve the water harvesting and incentivize the construction of ponds and microdams. We had microdam project here in Jamaica in the 70s, but it became politicized and stupid of us not to continue. The time has come for us to do that. To enforce laws to protect watershed. You can't have watershed sufficing our rivers and streams, and you have people up there every day cutting yam stick. It's rubbish. If we are going to have watershed, it must be protected. So we need those laws to enforce the protection of our watershed. We need to begin desalination as a national project. If the sea is right around us, why can't we get the water there with a desalination? Yes, it's expensive, but that water could be used for industrial use, to cool equipment and to wash down and sanitation and so on. So we need to look on where we can get water. It all has to do with food security. We need to rationalize the National Irrigation Commission to be contracted to private farmers who have water source on their private properties and to provide them with irrigation. What I'm saying, the National Irrigation is a government institution, and all it does is to look on government properties. It's too narrow focus when we are faced with the challenge of food security. It's not good enough. If the water source is good enough on the private farm, then you could sell the water to other farmers around. They need water. We need to select crops to create select areas to create man-made lakes for agriculture and domestic and entertainment purposes. Look on the size of this island, and the entire middle of the island is limestone based. Why haven't we created lakes in this country? I studied in Alabama, and when you go out for your entertainment in the weekend and you're on a lake, it's a man-made lake. We have done very little in this country to get water to our farmers. We need to redirect rivers and streams going to waste into established catchment areas. So what I'm saying, there are a lot of rivers going to waste in Portland. Why can't we channel them into the areas where they would recharge the Hope River and the aquifers, since we are depending on the Hope River to put water into the Hermitage Dam, or which one of them. We need to recharge them, and it's engineering work. It's not rocket science anymore. We would like to look on improve research capabilities, continue research on local dairy breeds such as the Jamaica Hope, which already has a high tolerant qualities for high temperature, but need more work. This animal was developed by one of our greatest scientists in this part of the world, Dr. T.P. Lecky, who developed 4 tropical dairy breeds, 4 tropical cattle breeds, 3 of them beef. The Jamaica Red, the Jamaica Black, and the Brahman are beef cattle breeds. And they were bred specially to stand up to high temperature. The Jamaica Hope, the milk breed, was bred specially to stand up to high temperature. And they were bred to be smaller beef and dairy cattle than what the Holstein and the Gerlanders and so on. Those are big animals. T.P. Lecky, the great T.P. Lecky said, we don't want a big animal in Jamaica with the terrain that they have to carry. And so he developed the Jamaica Hope to withstand temperature with a smaller udder. And I will say they give probably less milk than the Gerlanders and the Holstein, but they eat less. So at the end of the day, it's a more profitable animal. Work needed to be done on heat and drought tolerant crops to include our grasses. We have developed many grasses here with Dr. Dinsdale, MacLeod, and these people, but some of them, as the temperature rises, they die. And there are grasses in the areas that are close to the equator that we can breed and develop here to withstand the temperature. New bloodline needed for most ruminants to improve their conversion of feed to meat or milk, whilst being tolerant to adverse weather conditions. So we need to get a new bloodline, like the Jersey and the Guernsey. Research finding is imperative on the productive types and the effect of extreme weather on the reproduction. For example, in the high temperature that we are facing, which one of the following is more profitable for us to use? Embryo transplant, artificial insemination, or conventional breeding method. And the conventional breeding method is where you grow the bulls with the cow, but you have to feed the bulls. You can now import the semen and do artificial insemination and get a better result. More data is needed on open grazing. That is when the cow is just let go in a pasture. As against zero grazing, where you restrict their movement with respect to climate change and the effect of on ruminants, which are cattle, goats, and sheep. My closing remarks is that adverse climate change affecting sustainable agriculture must be challenged by adaptable research and the appropriate training for farmers and our consumers. And it is not beyond us to do it. Thank you very much for the opportunity. I hope I have fulfilled the requirements. Thank you, sir.
Now, I am about to say that I'm just gonna say I think we found the next topic for our science series, and a topic is science advancing Caribbean society, because Mr. Fulton said quite in a lot. He stressed very much research, 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 research. All the problems we are talking about, all the issues we're having, he's suggesting that can be solved with research, with the application of science, with the application of technology and appropriate application. And so, Mr. Fulton, I'm going to thank you for giving us our next topic. And out of what all you've done and all you've said, I'm going to say to you that research exists, and there is a student who did some work on looking at inventive ways of actually cooling the poultry. And there is a paper that's coming out that's looking on and a cheap, not AC, not acing the poultry, a cheap way of actually cooling the chicken. So there is work on the way already in tackling some of the problems that are there. And you alluded in some sense to the quality that's coming out. And with the quality that's coming out, the persons and where that gets ingested is where we're going next. So we are actually heading towards Dr. Brian Anthony James, and I'm sorry for calling out his full name, but he's the president of the Medical Association of Jamaica and head of the Department of Anesthesia and Intensive Care at the Bustamante Hospital for Children. Now, you know, there is no other way to introduce him than say he's a man from the East. He's St. Thomas born and bred and married with 2 sons. And his education is actually from the East in Morant Bay. He's a son of this faculty with a BSc in special chemistry before migrating to the wonderful MBBS program, right? He has a postgraduate diploma in general management from Mind, and he did FRCA at the Royal College of Anesthesia in London. He's a consultant in the Department of Anesthesia in intensive care, and he has authored multiple papers and multiple peer-reviewed journals. And his interests, ENT, pediatrics, sports, football, climate change, health. And I'm going to end you with world peace before I introduce Dr. Brian James to come to the stage.
Thank you very much, Mr. Moderator. I am really very pleased to be asked to be a part of this conversation, this really very important conversation. I will start off by saying that I am not a climate scientist at all. I'm a recent convert. I am a new apostle in this crusade of climate change. My Damascus moment came on June 11 when I listened to a lecture by the very, very accomplished Professor Michael Taylor at our recent seminar on environmental health. Since then, I've been hooked. So what I'm going to talk about today is climate change and health. I'm going to try my best to stay on one side of the divide. If you look at it, it's really 2 aspects to it. One is the impact of climate change on human health. And then the other side is the effect of healthcare activities on the climate and on global warming. So just to sort of get the one that we're so familiar with out of the way, the 3 main things that happen because of climate change: the heat, that we've heard about it quite a lot. The extremes of weather, we've heard about that a lot as well. And rising sea levels. And that comes from the heat, really. Now, the combination of those things have quite a bit of effect on human health. The severe weather itself can have direct infrastructure damage, injury, and fatalities, which then feed into the pressure on the health system, the requirement for the health system. The heat can directly affect human health by causing heat-related illnesses. There is no question at all that there is increased incidence of myocardial infarctions and with strokes and heart attack, as we need to say it in a layman's world, during very hot times. Also, its effect on non-communicable diseases is again unquestionable. So it increases the pressure on the healthcare system. Air pollution, which comes from the rising temperature as well, will exacerbate asthma. It also exacerbates cardiovascular diseases, and that includes more fatalities. There was a recent report in the newspaper about the increased numbers of people in A&Es around Jamaica awaiting admission to the wards, because unusually in June, July, they were having record numbers of admissions in a lot of the major hospitals. And I'm putting it on the table that this may very well have been because of the effects of the rising temperatures, vector-borne diseases. There are a number of people who are listening who might not be old enough to know the time when dengue was a fairly common disease. Then, sort of 20, 25 years past, when I, as a doctor, never heard of a case of dengue. Then now in about 2018 or so, we now have pretty much a dengue season yet again. And I can tell people that dengue is not a pretty disease at all. Because of the heat, the life cycle of the vectors, they are pushed to one side towards increasing reproduction and so on, and they therefore are able to transmit the virus much more readily. And so there have been outbreaks there is one outbreak of dengue, from what I'm hearing, going on right now. Similarly, waterborne diseases, we keep on hearing about lack of availability of water, and that there's an increase in the number of waterborne diseases. Allergies and respiratory diseases. Again, because of the heat, the reproduction of some of the allergens is greater, is enhanced, and therefore we have a greater incidence of allergies. We spoke about environmental refugees. People have to move from one area to another in search of water, in search of food, etc. Last year, well, since this year, there was a report again that there is a 26% increase in the incidence of suicide in Jamaica. I'm going to again put it on the table that this might be one of the effects of global warming, climate change. We spoke about the water and the food supply and the malnutrition that might come back. Over the past, again, 15, 20 years, we have seen pretty much a closure of the malnutrition wards in the hospital because somehow we've improved our nutrition. All of the programs that have been put in place have been successful, but we need to look out for the re-emergence of things like malnutrition. So now that I've taken out of the picture to a certain extent to deal with it in a very perfunctory way, the effect of climate change on health, I want to spend some time on the healthcare contribution to the heat. Healthcare and healthcare activities is a major contributor to the climate crisis. And our mission is to first do no harm and to heal the sick. However, we are a big contributor. And this is quickly evolving into a huge health emergency. We found there was a big study, a comprehensive global study, which found that our climate footprint is 2.0 giga, and I think giga is 10 to the 9. 2.2 with 9 zeros of carbon dioxide equivalent. And this was in 2014. It has actually gone up. And this is about 4 to 5% of the global net emission. The overall emissions, we are doing nearly 1/20 of it. If healthcare was treated as a country, what they've done is to rank the countries in terms of their greenhouse gas emissions. And if you take all of the healthcare emissions and put it on that ranking, we'll be ranked number 5. Only China, United States, India, and Russia would emit more greenhouse gases than the healthcare system. Think about that. the amount of greenhouse gases that we emit would be equivalent to the greenhouse gases emitted by 514 coal power plants. Right? Just think about that. And where exactly in the healthcare delivery system does this come from? Each one of the healthcare entities will either directly or indirectly release greenhouse gases while delivering care. And energy consumption and energy use for all the various activities is the main reason for all of our greenhouse gas emissions. And that comes also from transport, from manufacturing of the products that we use in healthcare. And I'm going to go a little bit more into those as we go. One of the entities that was set up to look at protocols and policies for and measurement of emissions managed to divide the emissions into scope 1, scope 2, and scope 3. Scope 1 would be direct healthcare related emissions, and that makes up like 17% of our footprint. That's just direct. This is from the vehicles that are used in transportation of our patients, transportation of our staff. Some healthcare entities, they actually make their own energy from fossil fuel related processes, and all of those, when put together, 17%. Then there are indirect emissions, and this comes from energy that is purchased, like from JPS in our case. And this makes up 12%. Most of it, 71%, comes from healthcare, from the healthcare supply chain, from the production of the things that we use, whether it is pharmaceuticals, whether it is the chemicals that we use, whether it is transportation, whether it is in disposal of the things, the waste material. And then some of it will come from food and agricultural products. So there is a huge carbon footprint from food and agricultural production. And we know when you go to the hospital, one of the things that we do not allow you to do is to starve, generally speaking. So we buy a lot of food. So 75% of the healthcare emissions are generated on the island, for example. So in our system, 75%, and it might be a little bit more because of how our economy is structured. 3/4 of it comes from outside of the country, and only 1/4 will come from within the country, and probably a bit less. And I'm going to say something about that particular bit of information. So this is a composite of all of what I just said. So let's look a little bit closer at the energy use, right? We spoke about 17% is coming from direct emissions and 71% from scope 3. When we look at all of the scopes, more than a half of the healthcare footprint is because of energy use. And it is primarily due to the consumption of electricity, gas, and steam. And I know a lot of people don't realize that throughout even Jamaica, there are many systems that work on the basis of steam, particularly for autoclaving. The health sector operational emissions are another sort of group of emissions. The other significant activities that contribute to the healthcare footprint include agriculture, and this is 9%, pharmaceuticals, chemicals, transportation, I spoke about that, and the treatment of waste, that is 3%. So overall, nearly 1% of the healthcare of all the emissions on Earth, right, is contributed to by healthcare's global climate footprint, which is nearly 4 million metric tons of emission. The use of anesthetic gases, and that's my area of expertise, and I'm going to speak about that a little bit more. That is 0.6%. And metered dose inhalers, that is something that I can guarantee you that there is someone in this audience right now. There are several people, 15% of this audience probably, who have used metered dose inhalers. I'm going to go into that a little bit more. So metered dose inhalers are typically used for the treatment of asthma and other respiratory conditions. They use hydrofluorocarbons as propellants, just like a lot of other spray devices. These gases, the hydrofluorocarbons, are highly potent greenhouse gases with warming potential between 1.5 and 3,000 times the warming potential of carbon dioxide. 1,500 to 3,000 times the warming potential of carbon dioxide, right? In Jamaica, we do not have the data. We do not know. Nobody among the climate scientists here today, I can guarantee you, can tell me how many metered dose inhalers we use per annum or per month or per day. We cannot be, we do not know how much hydrofluorocarbons are being added to the atmosphere because of metered dose inhalers. And here's where I'm going to add to the call from our previous speaker to appeal to the Faculty of Science and Technology at the University of the West Indies, of which I was a proud member, to partner with us on gathering data such as this. This is what is going to help us to make decisions about how we're going to mitigate climate change. The amounts that the numbers that we're seeing here are likely to be much higher because Jamaica is not in it, Trinidad is not in it, etc. Bronchodilators, which are the metered dose inhalers, are included in the essential medicine list, and therefore we cannot just stop using them. So what we need to do is to find alternative delivery mechanisms for metered dose inhalers. And there are some that are available. We need to start looking into making it widespread now, dry powder-based inhalers, etc. Anesthetic gases. I have to talk about this. I'm an anesthetist. I can't go anywhere without speaking about anesthesia. The gases used for anesthesia are potent greenhouse gases. The ones that are commonly used, and nitrous oxide in Jamaica right now, if I were to anecdotally guess, if you ever had surgery in Jamaica under general anesthesia, you would have at least an 80% chance of having had nitrous oxide. Nitrous oxide was alluded to earlier, and it is otherwise called laughing gas. Whenever I'm putting my patients to sleep, I start off with nitrous oxide, particularly the children, and I tell them that they're going to start laughing. And once you tell them that, they will start laughing. So I don't even know whether or not it's a nitrous. And then, in addition to the nitrous, we have fluorinated sevoflurane, isoflurane, and desflurane. The global warming potential of these gases range between 130 and 2,540 times the global warming potential of carbon dioxide. I'm going to say a little bit about desflurane, sort of anecdotal, or sort of, tangentially. Desflurane is like the perfect anesthetic agent. The moment you start it, the patient falls asleep. The moment you stop it, the patient wakes up. It has very little side effects. It is fantastic, but it is, well, one, it is very expensive, and for that reason, we have never used it in Jamaica. I have been warring with everybody that, why don't we have desflurane? That stopped since the 11th of June, 2023. I do not want any more desflurane because it is one of the most potent greenhouse gases, and they're trying really hard to expunge this demon from use in the UK, for example, and they've reduced it. Most of the gases, when we use them, in more developed countries, they scavenge them, but then at the end of the day, it goes into the atmosphere. Right? There are some countries that actually give us data on this. Again, we need to be able to tell the people, the planners, what is the extent of the damage being done by, sevoflurane is not a problem. Isoflurane is not a problem. Desflurane does not exist in Jamaica, but nitrous oxide. Right? I'll pass this over in the interest of time, just to say that different countries and different hospitals can have varying degrees of contributions of nitrous and fluorinated anesthetic gases. In Brazil, they actually measured it and found that nitrous oxide contributed to 75% of their direct emissions. And as I was telling you about desflurane, in the operating theaters in the United States, United Kingdom, and Canada, they were able to reduce their emissions, their anesthetic-related emissions, by 10 times. So it does make a difference, right? So to try and put this together a little bit, on one side, climate change threatens to disrupt the health system's ability to deliver high-quality care and to undermine all of the gains that we've made in public health in the past 50 years. And this is as a result of the heat waves that we've heard about, the extremes of weather that we've heard about, and emerging infectious diseases. We've heard about the dengue. It seems to me that we have a responsibility, a vital role to play in the climate change mitigation efforts. And we need, with the help of the scientists, to plan and implement substantial reductions in our emissions. And what the core benefits of this is enhanced patient care and staff satisfaction, and wholly of cost saving. The benefits that we're talking about, as I was just saying, prevent the initial health impacts of climate change and improve the well-being through the co-benefits, as I was talking about: cleaner air, increased physical activity, and more nutritious diet. It is well known that if we are able to convert much of the meat in our diet to plant-based foods, then our carbon footprint can be reduced significantly. There have been numerous very well thought out examples, but most of these, a lot of these, have come from situations in which people have measured the effects. And I'm calling again, I am appealing to our scientists to develop significant partnerships with the healthcare delivery system to, at the very minimum, measure our carbon footprint, measure our emissions, so that we are able to properly and rationally plan our mitigation strategies. These are some of the benefits. We spoke about them. If we put healthcare facilities near to access to public transportation, that's a bit more difficult. On-site energy generation, we heard about that just now in the farming community. That can be done, and that has been done in the healthcare facility. Natural ventilation, we're building a huge building in the West. I am hoping against all hope that natural ventilation and greening of the building itself is involved in that construction. Changes in health delivery, such as the use of telemedicine. People have demonstrated that the use of telemedicine has been able to reduce the carbon footprint of several healthcare delivery systems in places where it's measured. So we have a responsibility, since we generate 5% now of global greenhouse gas emission, we have a responsibility to be a part of the solution. We need to begin to reduce our own climate footprint and move towards net zero emission. We must retool in order to support decarbonization. If we all take actions towards this goal or these goals, they can be achieved. If we align healthcare development, growth, and investment with the goals, the global climate goals, we make up 10% of the world economy, and we can help to drive decarbonization and lead to a climate smart, more equitable, and healthier future. So in conclusion, health has a responsibility to align its action with the Paris Agreement, which is to try to reduce global warming, to the temperatures to below 1.5. I think we're at 1.1 now. Since we have the mission to protect and promote health, we need to implement this Hippocratic oath of first, do no harm. First, do not emit carbon dioxide. Go for net zero emission by 2050. That comes from educating the public and educating healthcare professionals. That comes from collecting, sharing, and using emission data in our mitigation planning. So I was looking for the question sign beside the tagline. It doesn't have one. I'm hoping that doesn't mean that it is saying that what is happening to us is too hot for us to handle. It cannot be. We are human beings. We were built to overcome. This is one of the things that we are going to overcome. There are options that are available. We, as Barack Obama says, are the last generation with an opportunity to do something about climate change. We must act now. Thank you.
Dr. James, I don't know whether I should thank you or I should run for the hills. So
Told you.
I don't know whether I should thank you or run for the hills. They say you may do something for many, many years, but you will learn something if you stop to listen. I've been an asthmatic for most of my life, and I've had many, many flares. As it gets hotter, I get more flares. Now, imagine I'm sitting here and I was expecting Dr. James to, what he summed up in one slide is what I expected his entire presentation to be about. He came from left field. I'm sure a lot of you were left scratching your head as I was. Health? We are supposed to be going there for the solution, not running to there causing a problem. And in essence, he didn't just leave the stage at the problem. He put his hat on as the special chemistry degree has taught him. And he put the hat on as the MBBS would have suggested. It is not terminal yet. There is an option. There is a way forward, and we can do something about it. I'm sure, like me, you are left wondering, am I really a part of the problem? But there is room for solution. And as we proceed to examine those solutions, I beg your indulgence as we try our best to bring our final speaker to the table. All right? Dr. Norbert Campbell is a lecturer, industrial hygienist, and public health inspector. Again, listen, guys, you've heard 15 years of experience, you've heard 20 years of experience. You are now going to be told 30 years of experience practicing occupational safety and health in Jamaica. Most of these years have been spent in the Ministry of Health, and he became head of the program. Dr. Campbell's contribution to the development of occupational health and safety in Jamaica includes being a member of a team that developed a suite of occupational and environmental safety health programs at the University of the West Indies, and became its founding coordinator and lecturer. Right? Dr. Campbell is currently a lecturer in the Department of Chemistry, where he coordinates the undergraduate and graduate program for OSH. We say OSH, OE, Occupational Environmental Safety and Health. All right. He has a BSc degree from UTech, a graduate certificate in industrial hygiene from the Gage OSH Institute in Toronto, an MPH degree from UWI with a practicum attachment. Guys, you're listening to somebody who has the experience and the acumen to speak to you. Please welcome me, and please join me in welcoming Dr. Norbert Campbell to the stage, please.
Thank you very much, Mr. Moderator. Good afternoon, colleagues. I had the pleasure of mine to participate in this forum, and time is of the essence, so I run along. In terms of introduction, another homeotherms regulate internal body temperature within really narrow physiological control methods, essentially by blood flow from deep tissue to the periphery. Radiation, convection, conduction, and evaporative cooling are the typical methodologies used. And that's the only system that the body has in terms of regulating heat exposure. About 25% of the heat generated is cooled at the skin in terms of convection, about 50% by radiative cooling, and about 25% used to warm inspired air. There are diverse indoor and outdoor jobs in hot environments, and there is quite a bit of work that has been done looking at hot environments in controlled settings. But particularly in respect of the topic in terms of climate change, my interest would more be on outdoor settings. As indoor settings, you can cool the space. It costs some more in terms of energy use, but solar panels and so on could use renewable energy to cool indoor spaces. But it's the outdoor space that is typically cooled by natural ventilation. So if outside is hot, then inside is going to be hot as well. Some typical hot environment, hot jobs, hot environments. You look at construction, which is this first worker here, the construction setting, and clearly he has some dust issue attending to that. He has a makeshift respirator there in terms of a kerchief. Agriculture, as Mr. Fulton spoke to, is a very important area of concern, and you can see that these women, you notice how they dress, and to do like fertilizer application or weeding sugarcane. Very, very hot situation outdoor. I beg to submit that their exposure is typically greater than sugarcane harvesting, because quite a bit of ventilation as the cane is cut down, but here the cane is in place. In terms of an emerging hot job situation, we speak about solar panel use as renewable energy, but then these workers are installing solar panels under very hot conditions, and we talk about the increase in temperature by earlier speakers. There's no shade there, right? And this last person, a vendor, is also an emerging situation. These jobs are going to become hotter as we go along. Another important issue is the burden of personal protective equipment in hot settings. Now you see that, for example, this worker being protected from exposures would have whole body suit, respirators, full face mask, as the case may be. And in a hot environment, you can readily appreciate the problem that would be there. This is a case of a welder, and he has this helmet, and this protects from ultraviolet radiation from the welding, but under this helmet, he would be wearing respirator to protect him from the fumes of the material that he's welding and the flux that he's using from the welding rod. These are workers who are wearing surgical masks because of COVID-19. And these workers are not normally exposed to hazardous, say, respiratory hazards in their workplace, but because of COVID-19 and the jurisdiction they are in, that's a requirement. And that imposes important considerations for them in terms of breathing in hot environments. Now, you'll notice that these are workers who have hot weather safety helmet, so that they are broader than your usual conventional hard hats. But you'll notice that they will not provide the amount of protection for, wouldn't meet ANSI standard for falling objects. So it is important that these considerations have to be taken into consideration in terms of hot environments, because these are additional burden that would be imposed. In terms of hot environment, we have heat stress, which is really the net load of heat, whether from internal metabolic heat and from environmental factors, and influenced to a great extent by the clothing that the person wears. Now, the body's response to heat exposure is what we call heat strain. And which is typically what is experienced by the worker as the body tries to adjust to this hot environment. Typically, 3 indices of heat strain: increased sweat rate. So in a hot environment, the body tries to maintain its equilibrium, as we know, body temperature 37 degrees Celsius. And the body seeks to retain that under any exposure situation. So it will sweat a lot. I think it's eccrine cells, I call them, that produce sweat. And acclimatized worker, and I'll speak to acclimatization in a moment, can produce up to 6 to 8 kilograms of sweat in a work shift. As a result of the workload, you also have increased heart rate. And in the process, there's increased loss in salt and electrolyte. So those are the 3 important indicators that would be of consideration in terms of heat exposure. Generally speaking, factors that influence thermal comfort, the air temperature, which is what previous speakers would talk about, we call that dry bulb temperature, the amount of moisture in the air, the amount of motion there is in the air. surface temperature. Also, the work that the person is doing, whether the person is doing very light work or very heavy work. And also, very important, the clothing that a person is wearing. Most regulatory regulations are geared based on a worker, we call a standard man, 70 kilograms in weight, body surface, skin surface of 1.8 square meters, and typically it's about 40 years or so, is what we refer to as the standard man. Now, other important considerations, secondary, age, gender, season of the year, cultural background, and so on, are also important. So in terms of evaluating exposure to heat, there are 4 environmental factors that collectively determine the extent of stress. The air temperature, the amount of radiant heat there is, the amount of moisture in the air, and the extent to which there is air movement. And as I said earlier on, what the type of work that the worker is undertaking and the clothes that they are wearing would be important. Now, it is also should also be noted that in terms of worker apparel, the clothes that they're wearing, most of the tests are done with a worker in a single layer clothing, most long sleeve shirt and pants. And that's so those workers who are working in open spaces, construction sites, and so on, who are probably bleaching and wearing warm clothes, they are at particular risk in those settings. The heavier the work that is done is the greater the extent of the risk. So we need to measure these environmental parameters. The dry bulb, which is the regular temperature, the wet bulb, which is the humidity, the globe thermometer measures the level of radiant heat and also the amount of wind movement, and anemometer would be used to do that. So in terms of the equipment, you'd have about 4 different pieces of equipment typically there, but there's a piece of equipment called the wet bulb globe thermometer that is used to measure those parameters. And these are examples of different manufacturers having heat stress monitors. This type here is what is called a personal monitor. That means you could put it on the worker. These are what we call stationary monitors, that you put it in the area close as possible to the worker, but this could be used, and the other one here, actually put it on the worker to determine individual exposure. And the interpretation of that result, the American Conference of Governmental Industrial Hygienists and the National Institute of Occupational Safety and Health in the United States, also ANSI, use the wet bulb globe temperature index as the guidance for exposure in hot environments. And what it speaks to here is that on the hour, they talk about work rest regimen, and these are, say, workers who are acclimatized and workers who are not acclimatized. And you'll see that at 29.5 degrees Celsius on a wet bulb globe temperature index, a worker could do a full hour at that rate. And that's the acclimatized worker. And you notice that the guidance for the unacclimatized is just 22 degrees less. And so as you increase the temperature in an hour at 32.5 degrees Celsius on the wet bulb globe thermometer scale, in an hour, that worker should be exposed to just 15 minutes of work and should be resting for three-quarter of the hour. And resting would be in a cool environment where the person is given, rehydration fluids and so on. But these are the guidance that typically use. And you'll always notice that for the acclimatized worker, they can work for longer periods in those settings. We seek, therefore, to consider how to control these types of exposures. In occupational safety and health, engineering controls is considered the gold standard. You always want to have some engineering control. And depending on the exposure situation, different approaches typically would apply. You can increase the air velocity to reduce temperature in a workspace. But most of the work is done in terms of workplace, work practice controls. Acclimatization, as I said, is the primary method of one of the primary method of control, where it is a method of exposing the worker to the hot environment in a methodical way. And what happens when it is done that way, that the worker produces more sweat and the heart rate is less. For the same work, the core temperature remains lower for the same volume of work. And there's less salt loss in terms of sweat production. And so it is important that workers are really acclimatized before they are put into hot environments. And this is some guidance as to, from NIOSH as to how workers can be typically acclimatized. For new workers, for the first day on the job, you'd want to expose them to about 20% of the duration. So some literature says 2 hours of the week. So you could split that 2 hours into 1 hour in the morning, 1 hour in the afternoon, but about 20% of the duration. And for every other day, you would go 20% more. And so within a week or so, and if you go, typically acclimatization takes between 1 and 2 weeks. And it'll be interesting to know how the worker manages these factors once they have gone through the process. Very, very important. And for experienced workers being off the job for 1 week or more, because the fact is that acclimatization is transient. You lose it once you're not exposed. Workers can go into cool environments for up to 2 days and they will not lose it. But if they are off the job for more than 1 week, they tend to lose this acclimatization and therefore need to be put back through the process for them to be, protected in the workspace. And you will go into, for example, a bakery, and you'll find that the worker, it feels hot to you, but you see that the workers might not be sweating because they have been acclimatized, and you are just going in the first instance. NIOSH has done studies looking at workers who have died from heat stroke over, I think, an 11-year period. And the majority of them died first day on the job because they were just put to the work in that hot environment without being acclimatized. And in terms of control practices, admin control, the buddy system is recommended where workers work in teams, and that would help, and to advise them to take water, work, and be in the shade, and to be able to report symptoms of heat-related illness. Take note of the weather. And I beg to submit as we go further, we are going to have more of these hot days. And so weather alerts we are going to be having going forward is my view. And so I need to take note of it. Then limit the time in heat and or increase the rest time in cool environment. Increase the number of workers who do the task so that more workers do the task and for shorter periods. But I am concerned about self-employed or contract workers. They do not have any supervisors. They are their own supervisors. Many of these workers do piecework, and they are paid based on the number of pieces that they do, or the sugarcane workers, the number of rows of sugarcane that you cut. That can be a problem, I think. Workers are to be encouraged to hydrate. Hydration is critical. And workers, if the heat is greater than 2 hours, they need to drink water every 15 minutes. And you can see this worker here is a construction worker, goes to work with his water and is being rehydrated there. Alcohol and drinks with high caffeine and sugar are of concern. So if the worker really works for very long in hot environments, maybe one would consider, sports drinks with added electrolytes in such situations. Rest breaks, highly recommended. that workers should be given break periods, permit breaks when a worker feels discomfort. I put a question mark there because that can be an issue where a worker might want more breaks than the supervisor considers necessary as against other workers, but there is individual peculiarities, and so that's an area of some concern. In many jurisdictions, this area is not legislated, and Jamaica has been struggling to pass harsh legislation for 25 years. So I'm really concerned about that. Now, in terms of new workers, assign them lighter work and longer, more frequent breaks. So there has to be a clear understanding of the importance here, and in the absence of legislation, that supervisors, managers will elect to do this, because as the days get hotter, a person who used to cut 3 rows of sugarcane in a day, let's say, for example, with getting some breaks, might not cut 3, 2.5 or so. They might make less money. And so the issue between the employer and the worker in terms of having an understanding of the importance of the increase in temperature and the need to protect workers' health under these conditions is really something that needs to be spoken to in terms of increased public awareness. And I expect that in the absence of legislation, that collective agreements would include these types of considerations. I see a role for the Ministry of Health, especially in the absence of the legislation, because many of these workers are in cottage type settings and are not under the jurisdiction of the Factories Act, and many of them self-employed. So I see a role for the ministry in educating and trying to monitor. Training constitutes a very critical component. Training of workers and supervisors in recognizing the symptoms, train them in terms of first aid. A worker has discomfort, maybe put the worker in a cool place, give some water. If the worker shows signs of serious injury, you would use cold water, and to the extent that even a cold water bath for immersion of workers who are particularly ill and seek medical attention. This is a new area for us, and we really need to have some education and also to speak to the importance of acclimatization, reporting and recording of symptoms that emerge. Supervisors have a major role to play in terms of how to implement acclimatization and the process to follow when workers become injured, how to monitor exposures, and even to be mindful of weather alerts that they know what to do in the workspace. So some additional considerations: pre-placement and periodic medicals for hot job employees. Now, pre-placement medical should be guided by the types of exposures that the worker has. And I think many times workers are provided support from practitioners without a clear understanding of the relationship in terms of occupational safety and health. So some education needs to take place all around there. Evaluation of heat tolerance among workers. Some workers are more tolerant to heat than others. Signage, and I beg to submit signage in English. I've seen signs that are not in English for workers who only speak English. And to engender culture of an appropriate culture towards heat stress. Some workers feel that they are macho and strong, and therefore they do not need this rest. Supervisors need to ensure that this is done for the benefit of the workers. One supervisor said to me that we don't employ children, the adults, but you'll find that the supervisor has a role to protect these adults. And those are my thoughts, ladies and gentlemen. Thank you very much.
Once again, I thank you so much, Dr. Campbell. I'm possibly going to use you to start the discussions and the questions that are about to come. And I'm going to play a little bit of an advocate, not the good kind, the bad kind. And based on your presentation, where you say when workers go off for longer than a week and they come back, they need to be reacclimatized. Should we then be giving 2-week vacations?
No, not at all. What happened is that because the acclimatization, it's so valuable, but you'll find that it is lost very quickly in terms of absence from that exposure situation. And so it has been found that any duration longer than a week, you would want to induct them again to ensure that they go through the same process. Because the value of it has been clearly established in terms of difference in workers who have been acclimatized. It's a 2-week process, right? So it's not that they need the vacation day, but once they get the vacation for whatever reason, once they're coming back, if they're out for more than a week, they should go through the process again.
Thank you for that. And I'm coming back to you, Dr. Campbell, but I'm going to go to Mrs. Spence first to kind of set the stage. So, Mrs. Spence Emmings, I'm going to just come to you. I'm just going to ask you very quickly, what is Jamaica's average temperature? What is around that average temperature?
That average temperature changes throughout the year, but in summer we were probably normally looking about 32 degrees Celsius. So it would be cooler from January through to about May, start heating up June, July. As I said, it would cool down starting August because we would normally expect rainfall during that period. So we would see a tapering of the temperature going on to December. So that's normally what we would see.
All right. So, Dr. Campbell, I hope you understand why I asked. In the table that you showed, that table never reached 30 degrees. And in the... Go ahead, Dr. Campbell.
Right. The thing, though, is that that table speaks to what we call the wet bulb globe temperature, which is a combination of dry bulb temperature, which the seven speaks to, which is that's the normal dry bulb temperature, and relative humidity and the amount of radiant heat. So that methodology captures those 3 important environmental parameters that impact, creature comfort.
Okay, Dr. Campbell. Thank you so much for that. Now, I'm sorry, I'm Dr. James, but I'm coming back to you. Forgive me, please. But you had me running for the hills. You had me questioning whether or not, I shouldn't probably just hold my breath and not use it at all. I honestly didn't know. Now, it is astounding to hear you say we do not know how much of these are in the country. And you again allude to the need for research and partnership. In an ideal world, what would that look like for you and this problem that you've alluded to?
All right, that was pretty much my objective when I was looking at what to say in this forum. Because I want us to get to a place where, 1, we recognize that this thing is real. 2, we recognize that it's urgent. 3, we recognize that we can do something about it. But 4, if we're going to do something about it, we need to measure it. And measurement in this kind of scenario would come from people like yourself. So somebody who is thinking about doing a doctoral thesis in one of the natural sciences could have this as one of their projects, or the department could develop a protocol for a study of the amount of greenhouse gases added to the Jamaican atmosphere by metered dose inhalers. And there are protocols out there for how to do it. It involves economists and scientists and measurements and so on, but it can be done. It's done all over the place. So that's what in the ideal world, that's what I think should happen.
Thank you. Thank you for that. And that leads me to just wondering. I noticed Mrs. Spence Hemmings mentioned bushfires. I'm just asking, has there been a shift in bushfires because of, as we move to warmer times, have we seen less or more incidents of bushfires? Or is it the case that everywhere just burn already?
Well, that I'm unable to answer that one. Again, I just believe that in our setting, we do not measure enough. I mean,
Okay.
a lot of the information that I want, I have to rely on, sort of developed countries, maybe because it costs a lot of money to do these measurements. But I don't really think that we measure enough. And I believe that the benefits to be derived from doing these measurements, things like what you're talking about, like, sort of air pollution I'm told that NEPA has like about 5 PM 2.5 detectors around the country. That's not really adequate for, giving us proper, good data on particulate matter. It's not really all that expensive, but somehow we don't measure enough, I don't think.
All right. Now, my final question. I'm coming to Dr. Blackwood, right? And this is going to probably spill over into the other spheres. There has been a push to increase Jamaica's housing density stock. How will they, having the density, this increase in density, impact the urban Eat Island, do you think?
Well, the thing I think about it is, I know people have been against high rises, but I think the issue is not the high rise itself. It is that the high rise needs to be balanced with the green space around it, or with the natural areas around it. So if people don't mind moving into high rise, because obviously land, we have finite land. And as a matter of fact, we might even have reducing land if we're looking at sea level rise, which would mean that you would have to go more vertical rather than go horizontal. But if you do that, there are policies, there are places, for example, like Singapore, where they have tons of high rise, but it's balanced with the green. So you will have the towers, and then you will have a lot of area of green space around it. As a matter of fact, they have vertical green, they've got green on the roof, so the building is covered in green. So even though it is going up, you have a more environmentally friendly approach. So one of the things that when I shared my presentation and I showed that particular building, in Jamaica, I believe, I am told that NEPA requires 20% of green space around the building. That's what I'm told. But that building did not show that to me. It was not evident to me that there was 20%. It was not even evident of maybe 5%. So maybe our policies would need to be adjusted if we plan to go that route.
Thank you, and thank you so much. The final person, he gave a wonderful presentation from the agricultural side, going back all the way to the 1970s to pull examples and stuff. But my question to Mr. Fulton is not quite a question. It's more a comment on some work that I saw done. And the work I heard about implied that they even took ruminants and put the ruminants in an AC room so that ruminants could actually produce enough the commercial viable milk, because as the heat got so much for the ruminants, they respired all the water, and so they produced less milk. I noticed you implied research, but the research you mentioned was largely around the variety of cows that we're choosing, and not so much on implying shade or doing other methods for cattle. Is there any other ideas you have that you think could work? I just want one from you, Mr. Fulton, before we go ahead, given the wealth of experience that you have.
Yes, I do think that we need to put more trees in the pastures so that you can have more shade. And we need to retrofit our present farm structures to be cooler. That comes through all the lectures this evening. We need to look on a redesign, but we don't know how to do it. So we are asking for research so that we have a certainty factor to move with. Because you see, in our agriculture here, we have roughly 300,000 small farmers, of which 250,000 of them have been registered with RADA, and they operate on 273,000 acres, a small plot, average 1.5 hectares or so. So it is not as easy to communicate to them unless we are certain. So you can't go and guess and spell, and then you change your narrative next week. And also to have researchers like yourself be linked into the extension service, because the extension is adult education. We are teaching farmers in what you call farmer field school, that is schools without walls. And we need people to lead with the research finding so that our average extension officer can extend this to our farmers. They are going out there now, they're like social workers, to ask a farmer, how are you doing? You're making enough money. That's a social worker business. That's not. And I used to head the extension service. You need to go to them with a program of development, with training, backed by a grass specialist, backed by a climate change specialist, where you can give every extension officer a tablet and the connection, the contact for somebody like you, where they can link you in the field and you text them and tell them something. That's where we have to take this thing now. But you need the research finding to do so. Thank you.
All right. Thank you so much to all my panelists. Thank you for your time. I know you are all very, very busy people. And typically work ends at 4:30. So I'm thanking you so much for each and every one of you for actually staying the extra time. I know we should have ended at 6. It's 10 past 6, but I thank you for all your time. Thank you for your valuable input. I'm gonna be very, very honest. I became a student once again. Each and every one of your presentations made me a student once again. So thank you so much for your time. And we are again, as I said, I think we found our next in the series. So if we come back to you, or some of you in some form, please don't hesitate to join us again. Thank you so much for your time.
Thank you.
Thanks
You're
for
very
having me.
much.
Thank you. It was a pleasure.
Thank you. Have a good
Thank
evening,
you too.
everyone. Mhm.
And
Thank
don't
you
throw away
very
your
much.
inhaler.
I promise I won't throw it away.